investigated, we from the University Hospital in Tübingen, the efficacy of the app in a randomized controlled trial, and the results of which I would like to present today. So let's dive into it. Here's a rough outline of today's presentation. And before I present the Negami app and the results of the efficacy study, I would like to talk about the clinical appearance of neglect and the current guidelines in Germany from the German Society of Neurology for the treatment of neglect, because I'm not sure if you are all aware of the unilateral neglect. The most common cause of neglect is large strokes in the area of the right middle cerebral artery. And in most cases, it is due to damages in the right hemisphere. And affected patients behave then as if their left side of the room or space no longer exists. So when searching for objects, exploration is oriented to the right side. Accordingly, objects or people located on the left side are ignored or not detected anymore. And I mean, this has consequences for everyday life. Patients overlook, for example, their half of the plate, so that only the food on the right is eaten, as you can see here in this picture. Or they get stuck with their left shoulder on the door frame. Or when applying makeup, they do that only on the right side of the face. And in the vast majority of cases, patients are not aware of their symptoms. In the acute stage, immediately after the stroke, eyes and head of the patients are often persistently oriented towards the ipsilateral, so the right side, even when the patient is addressed frontally. So as you can see here in this picture. And these symptoms described can lead to life-threatening situation. If you think about road traffic, for example, when a vehicle is approaching, so that can be very dangerous. And this underlines the importance of a fast and effective treatment. And many therapeutic approaches for the treatment of neglect aim to bring an increase in active orientation of the patients towards the contralateral, so their neglected side. And these training sessions are therefore also known as active exploration training. And as you can see here, according to the current guidelines in Germany, which have been published earlier this year, so also in 2023, active exploration training is the treatment of choice, along with optokinetic stimulation here and neck muscle vibration. And the goal of active exploration training is to increase the patient's active turning to their neglected contralateral side. And for this purpose, search training is performed, for example, on large projection screens or reading tasks or copying tasks, picture descriptions, and all these tasks that require active orientation to the neglected side. And what is very interesting and also mentioned in the guidelines is that active exploration training is particularly effective when combined with an active rotation of the trunk. And another interesting development that has found its way into the guidelines for the first time this year is that exploration training can be digitally extended to include, for example, virtual reality methods. And this increasing interest is also reflected by the exponentially rising number of publications in this area, as you can see here on this slide. Because when you search for the terms here, virtual reality and rehabilitation neglect on PubMed, you see that there's a number of publications with that topic. And digital extensions make a lot of sense when you consider the benefits for both the therapist and the patient, because on the side of the therapist, additional therapeutically relevant parameters can be generated, or results no longer have to be calculated manually, and that spares a lot of time. On the side of the patient, it means that in the best case, the patient has a refreshing change in the therapy and enjoys the therapy more. And let's not forget, we spare a lot of paper when we transfer paper pencil task into digital devices. But what exactly are digital or virtual extensions? We have to distinguish between virtual reality and augmented reality. Virtual reality describes a completely computer-generated simulation of an alternative world, whereas AR describes a computer-assisted addition of virtual elements to the reality. And while VR in most cases require dedicated hardware in form of a head-mounted display, you see that here, or also known as VR goggles, AR can be used with existing devices such as tablets or smartphones. And in addition to the cost aspect, because this hardware is very expensive, VR glasses have other disadvantages because users of VR systems regularly report symptoms which apparently occur so often that these symptoms have already been given their own name and are summarized under the term cyber sickness. And these symptoms include fatigue, dizziness, nausea, or blurred vision. And due to the interaction with the reality and AR, these symptoms usually do not occur. But despite the benefits of AR, it is very surprising that there's already a lot of literature, as I showed you here, in the context of rehabilitation and virtual reality. But with AR, there's no study that has investigated an AR system in the treatment of neglect before. So the following study is the first of its kind. And that was also our aim of the study, to test the efficacy of an augmented reality app called Negami and compare it to the current standard treatment of neglect. So what is Negami? Negami is an app, as I already said, for treating unilateral neglect. And it's an exploration training with augmented reality, therefore available for tablets. And patients perform two different types of tasks that require the active exploration of the contralateral side. And the patient sits during the task in a chair or in a wheelchair, as you see here. And the patient holds the tablet from left and side with both hands if he can, or if the patient is hemiparetic, he or she can hold it from the bottom in the middle or from the top in the middle. And with arm movements combined with the trunk rotation, the tablet can be moved through real space. And the first task is called Follow the Bird. And in this task, this virtual element, the origami bird, flies from the middle of the screen in sinus curves to the contralateral side of the patient. And the task of the patient is to hold this origami bird in this orange-blue circle during the task. So he or she has to follow with the tablet the bird. The task is successfully completed when the bird has finished its trajectory and the patient has transferred the bird into the circle. And then the patient sees the green check mark here. I hope you saw the video correctly because here it was a bit stuck, but I'm not sure. Yeah. So here you see another patient working on this task, task A, like from the other side, from the side of the therapist then. And what you also hear is that the patient receives auditory feedback when he manages to keep the bird in the described circle. And what you saw also here at the end of the video, this nice trunk rotation in this patient. The second task, task B, is called Find the Bird. And in this task, the bird is hidden in space and the patient has to find the bird And the bird is hidden on the contralateral side as well. The patient you can give the patient an orientation aid with this blue circle and this compass needle, but you can also turn that needle off if the patient isn't that impaired or doesn't have that strong neglect. Here you see another patient performing task B. Yeah, this patient already has a couple of training sessions with Negami because he already has a very systematic search strategy. So how did we proceed with our study? To test the efficacy of Negami, 20 patients with right-sided stroke and neglect participated in the study. And patients were randomly assigned to either the experimental Negami therapy group or an active control group receiving the standard neglect therapy in the respective rehabilitation facility. And patients were recruited in 3 different rehabilitation facilities in Germany. The inclusion criterion for the study was the presence of neglect. And in addition to the clinical behavioral observations, the diagnostic criteria had to be met in at least 2 of these 4 neglect tests. And we used the Bell's cancellation test, the letter cancellation, copying task, and line bisection task. So I'm not quite sure if you know this kind of diagnostic, so I explain that shortly. In the Bell's test, you have to find and cross out the Bell symbols. And in the letter cancellation task, the letter A must be found and crossed out as well. So these tasks are very similar to each other. In the copying task, the aim is to draw these 4 pictures you see here. And in the line bisection task, the patient sees several of horizontal lines, or horizontal lines are presented several times, and the patient must intuitively find and point out the center of the line, as good as he can do that. And those were the diagnostics. Shown here in the graph is our study design. On the one hand, the experimental Negami therapy group, and on the other hand, the standard neglect therapy group. And both groups were examined before and after the intervention in a total of 5 times. They were examined weekly. So 2 times here before the therapy, immediately after, and 1 week after. And the Negami therapy group received a second follow-up 1 to 2 months after the end of the training to see if the results remain stable or not. The training in the Negami group consisted, as I said, of 2 weeks training with 5 training sessions per week with 20 to 25 minutes each session. And in every session, they perform both tasks. So in the first half, task A, in the second half, task B. And the standard neglect therapy group, they received the same time amount, so also 4 to 5 training sessions per week over a time period for 2 weeks. And it consisted of visual exploration therapy and optokinetic stimulation, also 20 to 30 minutes. For each examination time point, so for each of the E points here, we used 5 tests, and I've already mentioned 4 of them in the context of the inclusion diagnostics. But in addition, a 5th test was performed, which we called the free exploration test. And it was similar to task B, so the patient was instructed to find a hidden bird. But in this test condition, no bird was hidden. But the patient's free exploration movement was recorded for 30 seconds. so that the mean horizontal degree of the exploration activity could be calculated. So let's move on to the results. Shown here are the results of the Negami therapy group in red and the standard neglect therapy group in blue across all examination time points for all neglect tests used. And due to the very similar results of the two cancellation tasks, they have combined into one graph with average values just for a simplified presentation. And in both groups, we found no significant difference between the measurement time point E1 and E2. So those time points before the intervention. And this indicates that there was no spontaneous remission. Therefore, these two values were combined into an average baseline value. And when we looked at the simple main effects between the baseline and immediately after the end of the training, so E4, we were pleased to find that both groups improved significantly. However, the standard neglect therapy group improved on only one of the neglect tests used, whereas the Negami therapy group improved on 4 of the 5 tests. And on a closer examination of the between group comparisons, we could find that the Negami therapy group differed significantly from the standard therapy group in favor of the Negami group from the first week of training, so from E3 on. And these improvements remain stable up to 2 months after the end of therapy. So all in all, these were very good and promising results for the Negami app. So that is why we concluded that the 2 weeks of training with Negami significantly improved the unilateral neglect in post-stroke patients, and these improvements were long-lasting. Thus, Negami can be used as an effective alternative or an adjunct to the current standard neglect therapy, and maybe even superior to it. So, the question of why the results were so positive may also be related to the fact that the patient enjoyed the treatment. Because in a previous study, we collected the subjective reports from neglect patients, as well as healthy elderly participants who trained with Negami. And it was shown that they had a lot of fun during their training and rated the use of the app as highly motivating. And as fun and motivation or enjoyment play an important role in a treatment success, this may have positively influenced the results. A second aspect that could have led to this positive results is that the exploration training with Negami included this additional trunk rotation, which could also have an additional therapeutic effect, as it was proposed in the guidelines I mentioned before. Because the active exploration training the control group received, they do not have this trunk rotation. Like some of this active exploration training is when the patient sits in front of a monitor or a computer, and you don't have the trunk rotation there. So through the practical and clinical use of the app during this research, the app was continuously developed and optimized. For example, a cloud synchronization feature was implemented, and that allows patients to practice on their own, and the therapist can retrieve the results asynchronously at a later time point, independent of the device. In addition, we have now implemented a voice assistant that makes it possible to operate the app purely by the voice without using the hands. And this cloud implementation and the voice assistant could be the basis for Negami to be used in the future as a method of telerehabilitation, so that the patient can receive further rehabilitation service even after their inpatient stay. But yeah, these are considerations for the more distant future. So there was an outlook. But yeah, after the just presented efficacy study, we have made the beta version available so that other clinicians can test Negami and provide additional feedback for improvement. And we also created a homepage with further information about the app in German as well as in English, and the option to register for this beta version. The beta version already included a cloud synchronization and voice assistant. And yeah, what we could see is that more than 50 hospitals and rehabilitation facilities worldwide signed up to test the beta version within a very short time. Now we are close or up to 100 institutions. But the problem with this beta version is that it is currently only available in German and for Apple products. So, however, as the Negami project has, so that was a huge problem, and we were thinking about like how to solve this problem. And the Negami project has won this year's German Brain Foundation Award for stroke research. And this prize money can also be used to translate the app into English and make it available for Android systems. And this should happen at the beginning of next year. So that after this international interest, the app can be used by anyone who wants to use it, at least for research purposes. And I say it like that only for research purposes, because in order to be able to use the app legally for treatment purposes, I mean, outside the research context, we have to CE certify Negami in Germany in accordance with the European Union's medical device regulation. And unfortunately, this is a very, very cost-intensive process, and a process that is so lengthy that it's not feasible for me, at least as a scientist, to do this process. From my point of view, it is important to make the app available, in the best case free of charge, like it is right now in a scientific context, to anyone who wants it. And the responsibility of whether or not the app is used in a scientific context would lie then with the user of the app. Yeah, and another project initiated by the study is the validation of the free exploration test. Because, as I said, we developed this test ourselves and used it in a part of the efficacy testing of the study. But this test is to be further validated in the future in order to investigate whether it can also be used for diagnostic purposes. And finally, I would like to mention that, it is very difficult to recruit large patient cohorts in the field of neuropsychological therapy research. And it is therefore all the better that another research group from Bielefeld, which is another city in Germany, is now attempting to conduct a multi-center study with Negami involving all neuropsychological outpatient clinics in Germany in order to achieve a larger sample size. And in the best case scenario, to further evaluate the efficacy of Negami. Yeah, as you can see, the study has generated a number of new ideas, which is, of course, for me, which makes me very happy as a scientist. And I think the important thing in this area of therapy research in neglect, and therapy research in augmented reality or extended reality in general, is that people inspire each other and work together in an interdisciplinary basis. or on an interdisciplinary basis. And I would therefore like to take this opportunity to thank the entire Negami team, interdisciplinary project team, consisting of Mr. Kanat, who is besides me the head of the scientific team. And I would also like to thank the software developers Thomas Schuster and Marian Lambert from XPace, as well as the designer Katrin Flammer from UXplain. And I would also like to thank the Hector Foundations, whose financial support made this project possible in the first place. And I would also like to thank Stephen Pedersen and Margaret Yu for giving me the opportunity to present the Negami research project in this context. And to all listeners of this talk, and thanks for your time and attention. And I'm happy to answer any questions you may have.
Thank you so much, Britta. What interesting and exciting research. I have seen 2 questions so far come in the Q&A, and please feel free to keep those questions coming, everybody. But just to start us off, I was curious myself. I noticed there were only 2 weeks of intervention total for both the Negami and the treatment as usual arms. How did you determine this? Is this the standard of care for this type of therapy?
Yeah, thank you for that question. So in Germany, it's like the average of rehabilitation stay is almost just 3 weeks. And those 3 weeks are covered by the health insurance in Germany. I mean, you can apply for an extension, and usually with this kind of disease neglect, this extension is allowed as well. But since they're not like for 3 or 4 months in the rehabilitation facility, that made it only possible to have the 2 weeks of intervention. It would be desirable to have that longer, but then I wouldn't know if I could have time for the diagnostics after the intervention. And I mean, that is important to test.
Okay. Yeah, thank you so much. That makes sense. And I did see there was only a follow-up of the Negami app group. Is that right? How did you how did you determine that?
So since there's already research on the visual exploration training, and also the results, or if the results are long lasting, that has already been tested several times. That is not new. So it has also practical reasons that we only did that for the Negami group, because 1 to 2 months after the end of therapy, most of the patients are not longer in the rehabilitation facility. So I have to drive to the patients to do all the diagnostic testing. And some of the patients are from the north of Germany, some of them are from the south. So the distance is very, very long. And the effort is very high to do this second follow-up. So we only did that for the Negami group.
Okay, yes, that makes sense. Thank you, Britta. All right, I'm now turning it over to the Q&A. I do see we have some questions coming in, and for everyone, remember to type in your questions in the Q&A chat, not the regular webinar chat. The first question that I see is, how does the Negami app measure or ensure trunk rotation? You noted that you trunk rotation of those that use Negami, and does the app measure it?
No, the app does not measure it. I mean, it would be desirable to measure it in a research context. Also to have the parameter how much input the trunk rotation gives in the treatment success, but it does not measure it. No.
Okay, thank you. I see another one. What are the considerations for the hardware choice? Since stroke patients usually suffer from motor impairment, have you ever considered to run the app on an AR glasses for patients?
Yeah, AR glasses we wanted to avoid, first of all, because of the cost aspect. And you only can get the trunk rotation when you have to like actively turn this device. So that is also our consideration against extending the app for smartphones, for example, because then you can only just turn your wrist and you don't have the trunk rotation anymore. So we that was an active choice not to use goggles, but to use the tablet. And also we want to have a tool that can be easily implemented in the clinical practice. And I doubt that any clinical practice has VR goggles already, but what they might have are tablets. And yeah.
I see. And that gets to the previous question too, of how does the app ensure trunk rotation? You're saying because of the size of the tablet, it ensures that the patient actually turn their whole bodies. Is that correct?
Yes.
Okay, thank you. And I think there's some confusion here with the attendees, the Q&A chat, not the webinar chat. Thank you all. Someone else wrote, thank you for your presentation. Do you know how Nagami and AR technology compare with the effectiveness of VR therapy for patients with neglect? So actually using the VR goggles.
You mean, sorry, can you repeat that? If there's already made a comparison between VR and AR?
Yes, correct.
Okay.
So it seems like this person is curious if the VR, if VR treating patients with neglect, how that compares to the Nagami app and just AR technology.
I mean, there is already some research. I can also show a slide. There is research on VR exploration training in treating neglect. I mean, that is why it also found its way into the guidelines, because there already is research on that, which showed that VR exploration training is effective in treating special neglect. But as you see here as well, there's some single case studies, and also with the same sample size, it's not that big sizes of patients they recruited here. But yeah, VR is effective. And I mean, AR with Negami, that was the first study of its kind. It would be nice if some other tools which use AR are developed in the future as well, to make a comparison. But I do not think that there is a difference between the effective or efficacy in VR exploration training and AR exploration training. I don't think that. I just think that the AR is easier to implement in the clinical practice, and also is maybe better for the patient, because it's a very specific group of patients. Yeah, you have to imagine the patients, stroke patients, are on average 60, 62 years old. So those patients are not digital natives. Yeah, and when you like give them a completely VR simulated alternative world, maybe they are overwhelmed and a bit stressed. And I think that's not a good start, or not good feelings which you should have during the therapy. And also the problem with the cyber sickness. I mean, that's a problem you have to take seriously. A study has shown that the symptoms remain stable for an hour, or even 1 day, 1 to 2 days after the exposure with the VR device. So also those are considerations which you have to take into account before starting a therapy.
Okay. So yeah, what I'm hearing you say is even if VR has efficacy similar to Nagami, you chose and wanted to use an AR version for reasons such as ease of use due to the older age and to minimize risk of cyber sickness, and then also
Yes.
just clinical ease as well.
Yes, exactly.
Thank you. Someone wants to know if the Nagami app is freely available to download on Mac.
On Mac, no, you have to have a tablet, but it is freely available for download. I think the process is that you check on the website and then write a message at the email address you want to use the app. And then Marian Lambert, I just introduced from the software developer, he will get in touch to you and yeah, it is available. Yeah. But still, this year or to the current status, only for Apple products. And next year, and I hope at the beginning of the next year, for Android systems as well.
Thank you. I see another question here. Any evidence to suggest that the durability of Nagami training may have been due to the intervention being fun and enjoyable? So I think this is referencing to the fact that you explained that Nagami may have superior results to just the treatment as usual. And you said maybe because that's just Nagami is fun and enjoyable, and this person is curious how that determination was made.
Because we collected subjective reports with different standardized questions, like there was a system of usability scale. Then we also collected data on the cyber sickness scale. It was simulator of sickness questionnaire, like this different questionnaires we collected, and from that we draw this conclusion that the patients had fun during the therapy.
Thank you. I saw someone is asking if you can show the website address again.
Yes, sure. It was, yeah. Okay. I think when you want to read it in English, it's not DE, but you can change that on the website as well.
Okay. Someone says, thank you for your presentation, the work your team is doing to make this available for researchers. Has your team considered using the tablet's inertial measurement units, IMUs, to quantify degree of rotation, smoothness of rotational and linear movements, etc.?
To use what?
So I think what this person is asking, and correct me if I'm wrong, is if you and your team have considered using whatever tablet, if the tablet has inertial measurement units. So the tablet itself quantifying and measuring the degree of rotation of the trunk, smoothness of rotation, or linear movements. Mm-hmm. So rather than just you seeing like, oh, the patient is moving his or her trunk, the device itself measuring that.
That would be great. I've never heard of such a feature, but I really want to get in touch with the person who suggested that, because maybe he or she can tell me what that kind of feature is or how I can download that, because that would be great to test. Yeah.
Okay, awesome. Thank you for that question, Austin. And maybe you and Britta can be in touch to discuss that feature. All right. I have another question for you. So I don't know if you've thought about this, but in future iterations of Nagami, what, if any, changes would you want to make to improve the app?
I think where the app is right now at this point, I wouldn't do any changes because we improved the app continuously. For example, at the beginning, with the start of the therapy, this process of hiding the bird in the second task, we did that manually. So I stepped behind the patient, then turned the tablet, then place the bird by touching the screen, and then give the tablet back to the patient. This process is now automatic, and those are all things or ideas which came up during the research. And as the software development team did such a great work, they implemented everything I had in my mind, and also like from the feedback we got from other clinicians during the this beta phase when they got the app. Also those improvements, Marian from the software development, he implemented everything. So at the current status, I don't have any ideas. I mean, if you have any ideas when you test Nigami, please write us, and we will see if we can change that.
Thank you. All right, so we have about 5 minutes left. So if anyone has any questions, definitely keep them coming. As for me, I'm curious, Britta, what's next for you in your research and your studies?
Yeah, thank you for that question. I'm from that study, and that was a very, very good study with such nice results. But I also saw that there's a lack of nice new tools for patients in the neuropsychological field, and I want to improve the treatment and make more patient happy with the treatment by itself. So I want to continue like this treatment studies, and for neglect patients, but also for other patient groups, like for stroke patients in general. I'm working right now at the day clinic for stroke patients. And also I want to extend the research on augmented reality, because I see there a lot of potential in this clinical context with that. Yeah.
Awesome. That sounds great. That's really exciting. And you're doing really amazing, great research in a field that definitely needs it. So thank you so much.
Thank you very much, Margaret.
This has been a really interesting talk. We have a lot of opportunities to use XR both for measurement and diagnosis and for therapy. This in particular is interesting in that it's been downloaded 100 times, which I think might be a tremendous asset to have a conversation with, to create a conversation with those 100 downloaders in terms of what their thoughts are, what their recommendations are, and you know, the somewhere along the line, at some point in the future, having the regulatory approval both in Europe, Germany, and the United States is an interesting opportunity, and the know-how and ability to do that might be within those 100 people who have downloaded it. So it's exciting from two standpoints. It's a good application for therapy that shows promising results, and also it's a open innovation opportunity that connects people around the world, and that that in itself is important. This is a fairly small small industry in medical XR, and connecting with our colleagues around the world is really important. So that's really positive. So I'd like to thank the audience for attending. I'd like to thank Britta for a wonderful presentation, and I think it'll make for good curriculum for the people interested in learning about medical XR. And then I'd also like to thank Dr. Margot Paul for joining us to moderate. Having a person with domain experience is so valuable when it comes to these talks, because it brings out so much more of value to the audience. So thank you for joining us again, Britta. It was wonderful. And thanks to all. We'll see you soon.